Yeah. All right. This is the 2009 AP Chemistry Free Response question number 5. And part A. In the boxes below, draw the complete Lewis electron dot diagrams for N2 and NH3. So the first thing you have to do is find how many electrons there are in nitrogen. And there are 5. And you multiply 5 times 2 because it's N2. And your total should be 10 valence electrons. And your Lewis electron dot diagram should look like this. So for NH3, you want to do the same thing on your periodic table. H has one valence electron, but there are 3 of them, so you multiply that times 3. And as we said before, nitrogen has 5 valence electrons, so 3 plus 5 equals 8, and your diagram should look like this. So for part B, calculate the standard free energy change, delta G, that occurs when 12 grams of H2 react with excess N2 at 298 Kelvin, according to the reaction represented below. So what you need to do is stoichiometry, and you start with 12 grams of H2, and for every 2.02 grams of H2, there is 1 mole of H2. And for every 3 moles of H2, there is 1 mole of N2. And you know that because of the equation up here. And for every 1 mole of N2, there is negative 34 kilojoules per mole. And so your total, when you add all that and multiply, you should get negative 68 kilojoules. Okay, so part C is given that delta H standard 298 for the reaction is negative 92.2 kilojoules per mole, which is larger, the total bond dissociation energy of the reactants or the total bond dissociation energy of the products, and explain. So you know the equation, delta H standard equals the sum of the bonds broken minus the sum of the bonds formed. And it's given in the problem that the delta H is negative. So you know that the bonds formed has to be bigger than the bonds broken in order for the delta H to be negative. So your answer will be the total bond dissociation energy of the products is a bigger number, which will produce the negative 92.2 kilojoules per mole.
So for D, the question is, the value of the standard entropy change, delta S, for the reaction is negative 199 joules per mole. Explain why the value of delta S is negative. So what you do for this problem is you look at your equation, and you know if delta S is negative, that means that you're becoming more ordered. So the evidence of that is that you're going from 4 moles to 2 moles. So that makes you become more ordered, so that makes delta S negative, because if it was positive, that means you're becoming less ordered. The next question is, explain why there is a temperature above 298 K at which the algebraic sign of the value of delta G changes. So you know from up here delta G was negative, so if the sign is changing, that means it becomes positive. So what you do is you look at your equation going home to supper, and so you know delta G is positive, and from before, delta H is negative, and so is your delta S. So if the delta S is negative, that makes the T delta S term become positive. So in order for delta G to become positive, this term needs to become greater and greater for that to become a positive number. So that's why increasing the temperature causes the sign to change. And then the next question says, theoretically the best yields of ammonia should be achieved at low temperatures and high pressures. Explain. So the first thing you do is you write out the equation of ammonia, so N2 plus H2 equals NH3, and then you balance. And you know that this is an exothermic reaction, so heat is on this side, the products, and you know that because NH3 is being formed, so you're focusing on bonds being formed. So at low temperatures, what happens if you lower the temperature over here? According to Le Chatelier's principle, the reaction is going to shift towards the products, so more products will be formed. And then if you increase temperatures, it always goes to the side with most moles. So we have 4 moles over here versus 2 moles over here. I mean, side with the least moles. So you have 4 moles over here and 2 moles over here. So the reaction is once again going to shift to the products. So that's why low temperatures and high pressures make the best yields of ammonia, because you create more product.